You interact with it pretty much every single day, but you've probably never actually seen it. It's this hidden technology that makes our most critical systems incredibly fast. Today, we're pulling back the curtain on embedded SQL, the code within the code. So, have you ever stopped to wonder how a bank can process your transaction in like a split second? Or how a giant global retailer manages millions of items in real time all at once? The secret is all in how these massive applications talk to their databases with just unbelievable speed and reliability. And for a lot of these super high-performance systems, the answer is a technique called embedded SQL. And honestly, it's exactly what it sounds like. It's the practice of putting SQL database commands directly inside the code of another programming language, whether that's C or Java or even Python. Okay, the best way to picture this is to think of it like having a native translator living right inside your code. So instead of your application having to make a separate, kind of slow call to talk to the database, the conversation just happens directly. It's a fluent, direct line, no delay, no middleman. So how does this whole thing actually work? Well, it's really a three-step process. First, a developer writes their code, just mixing the SQL commands right in there with a language like C. Then, and this is the magic step, it goes through a pre-compiler. This special tool scans the code, finds all the SQL, and translates it into function calls the main language can actually understand. Finally, the whole shebang is compiled into one super efficient program. That pre-compilation step, that is the absolute key to its amazing performance. See, by processing and optimizing the database queries before the app even runs, you get this incredible efficiency. The database basically has a perfect game plan ready to go, which just slashes the processing time when the application is live and under pressure. Let's look at a classic example in C, just to make this real. See that exec SQL prefix? That's basically a flag, a little wave to the pre-compiler saying, hey, this next part is for you. And those colons in front of employee name and employee ID, that's how variables from the C program itself get passed directly into the SQL statement. It's that super tight integration we've been talking about. Now, this isn't just for older languages like C, not at all. In Java, the same core idea is done using something called a pre-prepared statement. Yeah, the syntax looks a little different, but the principle is 100% the same. Prepare the SQL query ahead of time for optimization, and then just plug in the variables whenever you need them. And you guessed it, the same pattern holds true in Python. Here, a cursor object executes that pre-written SQL with placeholders for your variables. It's a different language, a different style, but the guiding principle is exactly the same. Prepare the query for maximum efficiency. Okay, so all that power sounds amazing, right? But there's always a trade-off. The big advantages are just raw performance and efficiency. But the disadvantages, they're pretty significant. The code becomes way more complex, it's not easily portable to other databases, and trust me, debugging can be a real headache. Now, given those downsides, you might be thinking, this sounds like some ancient technology that we've kind of moved past. So the big question is, why does this thing still power so many critical systems in our modern world? The answer is that for certain industries, those trade-offs are totally worth it. In these high-stakes fields like banking, massive-scale inventory management, and enterprise planning, raw performance isn't just a nice-to-have, it's completely non-negotiable. For them, the rock-solid speed of embedded SQL easily outweighs any of the complexity. And here's where you've almost certainly seen this in action. The next time you're at an ATM, that split-second response you get right after you enter your PIN, yep, that's the kind of speed and bulletproof reliability that this technique delivers. It's the hidden engine making sure your transaction is fast, accurate, and secure. So, what is embedded SQL? Is it an old relic, or is it a hidden powerhouse? You know, the truth is, it's kind of both. It's a testament to a design that is so hyper-focused on performance that it remains absolutely essential for the systems that just can't afford to slow down. It really makes you wonder, what other old tech is still quietly running the world all around us?